is actually fairly simple. If you don't get it right, don't panic. I'm not trying to insult you here, but try and write something on your own. During normal semester, I would stop the class and just let you write for a minute. I would give you a little bit of time to draw, see if you can surprise yourself, and then confirm. Are you following along? Does it make sense? Are you getting what I'm hoping you're getting out of this? If you're not, I'll give you the answer. Now's that time. None of these portions of the molecule change. The thing that changes is we're forming a new bond here. It's with chlorine. The other chlorine is now chlorine radical. So what we've made now is our product. And notice that in the second propagation step, we have regenerated a chlorine radical. We've regenerated this chlorine radical. And now, since there wasn't much chlorine radical made in the beginning, we could actually shut the light off on the reaction once it gets going. That first chlorine radical finds a methyl group, or a methane molecule, reacts to make HCl. Now chlorine's happy, but the methyl group is not happy. The methyl group the methyl radical finds a chlorine molecule. It forms a stable covalent bond with chlorine, and it regenerates this chlorine radical. This chlorine radical then gets pumped back into the propagation steps. There's another molecule of methane floating around in this reaction. There are billions and billions of molecules we put in a reaction. It's not just one molecule of Cl2 and one molecule of methane. There's billions upon billions of these methane molecules. We generated a little more chlorine radical, and it starts this cycle again. Chlorine radical goes back, it finds an unreacted molecule of methane, and this process continues and continues until the amount of methane keeps decreasing, the amount of CO2 keeps decreasing, and we ultimately get HCl, and we get our methyl group here. This is the most important mechanism in radical halogenation reactions, these two parts here. This initiation step's important, practice it, but whenever we're doing this reaction, the two propagation steps are going to be the critical ones for you to have good knowledge of and master. So practice these the most. We're always going to have a chlorine radical or sometimes a bromine radical, we'll see next class, reacting with some sort of alkane. Methane is obviously the simplest alkane. That's the one we spend together on our first introduction to it, the simple molecules. Okay, key points. We get one radical, starts the process. That's the first propagation step. The radical changes places by a series of logical steps. And finally, we finish the reaction when the methyl radical finds an abundant amount of Cl2. These two things react with one another and give our product. There are a variety of steps called termination steps. So we have initiation, propagation, and termination steps. Given the fast pace of this course, termination steps have never been the most important part for us in our knowledge and our discussion of this, but there are 3 termination steps, and we're not going to put them on paper because I really don't want you to get confused with them, but they generally involve 2 radicals finding one another and kind of killing each other like this. Basically, it's the destruction. Termination steps are destruction of 2 radicals. These are not productive in our reaction. They don't help us explain the formation of methyl chloride from methane and chlorine. And again, we're not going to fixate on them. I'm not going to put them in paper. They're in your notes. You won't need them again for some time. Question came in, will this methyl radical ever find another molecule of methane and do something other than this, right? So inside this reaction, when we make this methyl radical, it goes out and now it's hunting for an electron. And the choices it has are either a methane molecule, which there's lots of, or a chlorine molecule. It turns out the chlorine molecule is the best choice because this bond is the easiest to break. So if it actually wants to find another electron, there's another methane molecule. There's billions of them floating around, but this is the weakest bond, the best source for it to get an additional electron. So we'll practice this many, many more times, I promise. But the 2 steps you always are going to have to repeat and practice quite a few times because this isn't intuitive. chlorine radical that came from the initiation, which only happens once, makes methane, meets methane, makes an HCl bond, methyl radical continues through this sequence. So yeah, these things were hunting for electrons, and the most favorable one for chlorine to find is this one. We're going to look at the energetics our next class, and so we'll get to that particular issue. Finally, the termination steps, they were in your pre-lecture slides. And again, I don't even want to draw them this summer, really for your benefit. I don't want you to be confused by them. I've been doing organic chemistry for a significant period of time now in my life, and I know that it's not that terribly important for us to study these things with any great detail. Okay, we're going to do a quick little summation here, just in writing, write them out. There's some key points that you need to have at your disposal. I narrated some of these points, but I want to put these, they're so important, we're going to put them to writing. So we're going to talk about these radical halogenation reactions with alkanes. These are some key points. We did chlorine and methane. We could do bromine and ethane. But in general, it's going to be called a radical halogenation. Whoops. This is a halogenation reaction with alkanes. Key points. Number one, first bond to break is the weakest bond. So we heat methane and we heat chlorine together, and the first bond that's going to break is the weakest one. This leads to a cage reaction. This is the one that we described as the initiation step. The initiation step is where this particular first event transpires. And the key point about this initiation step is very few chlorine radicals are formed that escape. Very few of these radicals that are formed escape. And we don't need a lot of them, because we saw in the second propagation step, every time we make a molecule of methyl chloride, we make another chlorine radical. So the process is self-sustaining. It internally keeps generating and chugging out chlorine radicals. So it keeps going. Well, let's say the second key point here is that once we enter the propagation steps or propagation phase, first thing we'll have is that chlorine, let's say, steals an electron and hydrogen from alkane. Okay. Chlorine is going to steal an electron and a hydrogen from an alkane carbon-hydrogen bond. We might get to the reaction geometry. I'm just going to make a little bit of points about this. This particular reaction must be collinear. Let's write this into our notes for now. This reaction, when chlorine radical reacts with a carbon-hydrogen atom, must be collinear. We may or may not describe exactly what this is in this class. It's absolutely okay. And the result is a new bond. And that new bond is HCl. And we form a methyl radical. So we're just orally, or I guess writing our way through what's happening in these reactions. We enter the propagation phase, and it starts with chlorine radicals stealing one electron and a hydrogen from an alkane. This reaction must be collinear. We may or may not talk about that this semester. But the key points is the result is a new bond that's formed. We make HCl, and we form a methyl radical. Third step, or the third key point, is the continuation of the propagation step. The methyl radical reacts with Cl2. This is a collinear reaction. Okay, again, this word collinear, I don't think we're going to talk about it at any great length. Just put it in our notes. Just want you to have it at your disposal. I won't test you about this particular idea. But the methyl radical reacts with Cl2, and this results in product formation. In our case, CH3Cl. Right? Our methyl radical wants to steal an electron. It gets it from the chlorine-chlorine bond. It also gets the chlorine atom with it. So we result in the formation of methyl chloride. The other key point is we regenerate a chlorine radical in this step. And this is what allows the reaction to propagate or to continue. Another way these reactions are called not only just propagation, but sometimes they're called radical chain reactions. Sometimes these reactions are called radical chain reactions. And that just means that if you look up what a chain reaction is, most people understand this. It's just this uncontrollable process or this vastly rapidly repeating process. There's a fourth key point we're going to gloss over this particular summer. I want to see what happens if I don't teach you what termination is. I think you'll have a better chance of success with these particular ideas, focusing our sole attention on initiation step and the two propagation steps. I think I will talk just a little bit about what this collinearity is in the time we have together. We have plenty of time, the pace that I'm making this class this summer. So we're going to talk specifically about what collinear means. It's kind of an interesting idea. It's not going to be something I test you on. It'll just be something for us to further practice, however, these types of reactions.